All right, question 8 here. A rectangular table has an expression of this. Determine the algebraic expression for the length and width of the table, and then there's a B and C. If R is 2, determine the area, and if R is 3, determine the perimeter. Okay, so a little bit different. We'll get to a new page here. 50R squared plus 10 minus 12. Plus 10R minus 12. Okay, we know that we have a rectangle. There we go. And with that rectangle, what we're going to do is we're going to do some factoring to figure this one out. So we know the expression, the area of it is the expression we have over here. And we want it to be a pair of factors. So we want it to be a length and some width. So what we're going to do is we're going to do factoring to kind of hopefully get to the bottom of what the length and width are, and then we'll use that information to solve B and C. So we'll use that fearless factoring we used before. Now this one will have a lot of factors in number 50, so there's going to be a lot of columns on this one, and same with the number 12. So we'll have to do a little bit of educated guessing as we go through. So we have 1 and 50, 2 and 25 is a set of columns. 3, no, 4, no, 5 goes in. 6, no, 7, no, 8, no, 9. Okay, so that's it. We have 3 sets of columns, and 12 is the same. 2, 6, and 3, and 4. So we have 3 sets of columns to work through. That's a lot of combinations to try to solve. We know the products got to add up to positive 10. I'm getting the feeling that no matter what we multiply by 50 is probably not going to work. And even the same idea with 25. So I'm going to do some educated guessing and assume that this will be the column we work with. And then I'm going to guess again, 10 and 12, probably not going to work out. I could do a quick guess, 10, yeah, that one's not going to work. 60, 20, and 30, this is a possible column. And 30 and 20, this is another possible column. Okay, so with some quick estimating, I think I may have narrowed it down here. So we're going to test these out. 10 times 2 gives us 20, and 5 times 6 gives us 30. In order for this to work, I would need the 20 to be negative. That works out here because we need one of these to be negative. So that works out perfectly. 10 and negative 2 gives us negative 20. 5 times 6 is positive 30, and that equals the sum. So we can set up our product now. We know that these will be the first term, so one of them will be 5R, the other will be 10R. Okay, and now because we did 10 times negative 2, they have to go in opposite brackets. And because we did 5 times positive 6, they have to go in opposite brackets. Okay, so we have something here. Now, if you quickly look at this, I can actually factor this one even farther. And I could have started from the top. I didn't realize I could do some common factoring to pull out a value of 2 here. But we can just do it after the fact and pull it out of this number here to make things a little simpler for us if we like. So what I'll do is we common factor the number 2 out. So we divide each of these by the value of 2. 2 will come to the front of our equation. We'll still have 5R minus 2. And we'll have 5R plus 3. Okay, so this is going to be our expressions of length and width. So let's build up our rectangle a little. Now, assuming that R is always going to be a positive value, 5R minus 2 would probably be the shorter side, where 5R plus 3 will probably be the longer side. Question B says, what's the area if R is equal to 2? So what that means is we just got to substitute in for R and calculate the area. So we can do that pretty quickly. This would give us 5 times 2 minus 2, gives us 10 minus 2, which is 8. This would give us 5 times 2 plus 3, gives us 10 plus 8 is 13. So all we need is our 13 by 8. Oops. And that gives us 104. So the area, if R is 2, should be 104. Okay. The other question said, what is the perimeter if R is equal to 3? So a little bit different. In this case, we'd have 5 times 3 minus 2. That's 15 minus 2 is 13. And this 5 times 3 plus 3. So 15 plus 3 is 18. Okay, so what that means is this side is 13 in length and this side is 18, but perimeter is actually the addition of all of these. Or technically adding them together and multiplying by 2 because it's a rectangle. We could use that concept. So we know that we'll have 13 plus 18 times 2 because the perimeter is of a rectangle. Okay, so this gives us 2, gives us 31, I think. So our perimeter in this case should be 62 units, whatever the unit is in this question.